we are going to discuss some important questions that is basically specialized for interview. So let's start with the first question. So our first question is, what is the decimal equivalent of the hexagon number 0x3? So can anyone tell me how to solve it?
Hi, hello. You can either convert it into decimal and then to binary, or you can straight away convert it to binary using that split into 4 bits, right? Each hexadecimal to 4-bit binary. So we'll get that.
What do you mean by 0x here?
Actually, I'm not. I think it's a presentation of address. I am not sure actually.
0x is used to denote that the number is a hexadecimal. It's just a notation to denote the number. It is a hexadecimal. Now the main portion of that question is 3a. We have to convert that 3a into decimal number. So what will I do is that we in a hexadecimal number, the number is from 0 to 9 as decimal number, and A is denoted as 10, B is denoted as 11, C is denoted as 12, and go on to 15. Okay, so we will calculate. We will first resolve the value of A in number form. A can be denoted as 10. So we multiply the value of 10 to the 16 to the power 0, because the position of A here is 0th position. So A is multiplied by the value of A, which is 10 into 16 to the power 0, plus the second number is 3. Now we multiply 3 into 16 to the power 1. So it can, let me use the whiteboard. My screen is visible to all?
Yes, sir.
So here, A can be written as 10. In hexadecimal number, we have number from 0 to 15. 0 to 9 is same as decimal number, and A is denoted by 10, B is denoted by 11, and so on, like up to 15. So here A is denoted by 10 into 16 to the power 0, plus next number is 3 into 16 to the power 1. So we can calculate is 10 plus 48, 58. So hexadecimal number can be converted into decimal by directly using, as we do in decimal form, we can do it in hexadecimal. But the main difference is the 16. We use 2 to the power base, while when we convert binary to decimal, here we use 16 to the power base. 16 to the power base 0, base 1. Suppose we have another value 3a b. In that case, we will use B value is 11 into 16 to the power 0, plus A, the value of A is 10 into 16 to the power 1, plus 3 into 16 to the power 2. In this way, we can convert hexadecimal number into decimal number. Any doubt? Any doubt so far?
Actually, right, not a doubt. You told like 0x is representing hexa, right? So what is the notation for octal?
we have different format. The notation which are we using, we can change the base according to the notation. So
No, I'm asking here in starting 0x, you told it represents x, right? So if you're given an octa means how you representing the similar form?
okay, you have to convert it in octa.
No, actually
So
convert is fine. I'm asking the notation here. In the exa number, you told the 0x represent the exa, right? So is there any equivalent for octa?
uh, for octa representation, we generally use O. O. If
Okay, I think
number is
okay,
denoted by O, then we can define is that we can say that the number is octa.
okay. Thank you.
So our next question is, what is gray code? What are some benefits of using gray code over binary code? Can anyone tell me what is gray code? Am I audible? Can anyone tell me what is gray code? And what are the advantages of gray code?
The gray code is a number system in which consecutive numbers only differ by one bit. And the benefit of using it is that when we go from one number to the next number, only one bit is changed, and because of that, the chances of error are very less of accidentally changing another bit. So only if one bit is changed, so it is much safer.
Okay. What type of code is gray code? It is weighted code or non-weighted code? Hmm.
Non-weighted.
Okay. So basically, the main advantage of using gray code over binary code is that in gray code, when we go from one number to another number, one code to another code, only one bit changes at a time. But it's not so in binary. In binary, the code changes from one position to another position, maybe two or three or in any number of times. So the chances of arise of ambiguity in binary code is high, because we are doing more toggling in binary code, but it's not so in gray code. In gray code, we are doing only one toggling. Toggling is not good because it arises a chance of ambiguity in any circuit. So the main advantage of gray code is that only one bit changes at a time. So it's very useful. Arithmetic operation becomes easy, and when we use gray code in programming or in Verilog, so computation process, arithmetic process becomes easy. And uh, suppose we are changing from, suppose we have any any.
Yes, sir.
So in gray code, suppose we have number 010. In binary code, we are changing from 010 to 111. Or suppose uh, we have a number. So in binary code, when we are changing from this to this, we see that there are two bits which is changing. So two number are toggling from 0 to 1. So the chances of ambiguity increases while using binary code. But when we use gray code, only one bit changes at a time. That is the main advantage of gray code. So now how to convert a binary code into gray code. For that purpose, suppose we have any binary code 01101. In order to change it into gray code, we will write the MSB as it is 0. Now from here we will check that if the number is toggling, we write it as 1. If the number are same, we write it as 0. So either here we are changing from 0 to 1, a number is toggling here, so we will write 1. If the number are not toggling, it is same, we will write 0 here. In similar way, the number is toggling here, we will write 1. The number is also toggling here, we will write as 1. So in this way, we can convert binary code into gray code. And now suppose we have gray code and we have to convert back into binary code. So we will write 0 as it is. Now we will check from these two. If the number is toggling from 0 to 1, then we write it as 1. Now we will check from this number to this number. If the number is toggling again, we write it as 1. Now we check from 1 to 1, the number is not toggling here, the number are same, so we will write it as 0. Again we check the number is toggling from 0 to 1, we write it as 1. So in this way we can convert gray code to binary code to gray code, or gray code to binary code. Any doubt? Any doubt? Hello? Hello, am I audible? Hello?
Yes, sir. You're audible. Yes, sir.
Any doubt?
No, sir.
Okay. And also one advantage of gray. Okay. Now, what is parity bit and how it is computed? Can you tell me about the parity bit?
For error checking, sir.
Hmm?
For error checking.
And how it is calculated?
Number of ones in the transmitted side is equal to in the receiver side the data. We assure that the data would not be changed. Even parity and odd parity, both we can take.
So there are two types. Generally, parity code is used to detect error in while we transmit message from transmitter to receiver. There is chances of injection of error in between the path. So parity bit helps in computing that error which is present or not. So through parity bit, we can check that the message signal which has been transmitted is pure or not. So these are the main application of parity bit, and mainly there are two types of parity bit. That is even parity and odd parity. When is even parity used and when odd parity is used. Suppose we have any binary number 01101. Here the number of ones are odd. In this case, we use even parity and we add an extra bit, that is 1, and makes it an even parity. So if the number of ones in any binary code is odd, then we use even parity and add one extra bit in the number to make it even parity. Similarly, if we have suppose we have even number of ones in any binary code, then we at that time we use odd parity and add extra bit, that is 1, to make it odd parity. So these are the two, mainly these are the two parity code, odd parity and even parity. And now let us calculate the application of parity and how it's.
Excuse me, sir.
Mm,
Yeah, this is Hemant.
Okay.
Hello?
Ask.
Yeah. So parity bit is always 1. Can a parity bit be 0?
No. Parity bit cannot be 0. It is always 1 because it is based on the concept of XOR and XOR. So that's why we use parity bit always 1. If we use 0, then XOR and XOR concept will not be used and it will not act as a add, improve, or detect error in the message. So now I will do you have any idea of KMAP? Anyone have idea of KMAP? So these are the 3 inputs ABC, and we have odd parity. Odd parity is applied when the number of ones is even. Here the number of 1 is 0, that is even. So we will apply 1 here. Here the number of 1 is odd, we will apply 0 here. Here the number of 1 is odd, we will apply 0 here. Here is the number of 1 is even, we will apply 1 here. Similarly, we will apply 0. If the number of 1 is even, we will apply 1 here. 1 and 0. Okay. So we can directly say that the output is A bar, B bar, C bar plus A, B bar, C bar plus A, B bar, C bar plus A bar, B bar, C bar. Any doubt in this equation? Anyone have doubt in the output? Anyone have doubt? This uh, this 4 are this 4 have output 1. So here the output is 1. We take A bar, B bar, C bar to make it 1 because here the input is 0, 0, 0. Similarly here we have 0, 1, 1. The output is 1. We will make it A bar, B, C.
The second one.
A bar, B, C. Here A0, A bar, B, C. This equation comes from the K-map. So I'm not writing K-map in detail. I'm directly writing the equation. So here the value, this equation is 1. So A, B bar, C. Now here this value is 1, A, B. A, B, C bar. Here is my output for odd parity. So how will you calculate this output? A bar, when we take A bar common from first to B bar, we can directly write is B X nor C. Okay. Indirectly write it B X nor C. Plus, when we take common from here A, we can directly write it B XOR C. A we to take two common from A bar and it be B bar C bar plus BC, which is B XOR C. Here we take common A from this and this. Here it's come B XOR C. So from this equation, we can directly write that the equation is A bar B. Suppose we take B or C as X. So the equation becomes AX plus AX bar. AX plus AX bar. Okay. So this equation becomes A or X. And X is what? A or X, we can write it from here, B or C. A or B or C. Any doubts so far? Sorry, here is a mistake. We have taken B or C, so here it is X, here it will be X bar. So here it is AX nor B or C. So odd parity, we have generated the equation for odd parity, and it can be written it as A, B, and C. So A and B are X nor. We will connect A and B with X nor. And the output of that X nor will be connected to the XOR. So in this way, we have generated the circuit and the equation for the odd parity. What is the main advantage of odd parity here is that when we are transmitting any signal from transmitter to receiver, if there will be any change in the bit, suppose we have 0, 1, 1, 0, 1. Suppose this is my binary number which I am transmitting from transfer to receiver end, and here I have added one extra bit, that is odd parity. Now if there will be change in the original code, suppose there is transition from 0 to 1 or 1 to 0, the number of 1 will change from even to odd, and it will not act as an odd parity. The output of the final odd parity will change. So in this way, we can detect the output, we can detect the error in the message. Anyone have any doubt? Are you getting what am I telling? Suppose we have any message 0110 which I have to transmit, and we have to confirm that the signal which has been transmitted is received by the receiver or not. So here is my original signal. What I have done is that I have added extra bit, that is odd parity, because the number of 1 is even. So we have added 1 odd parity, and odd parity, the output of the odd parity will be according to that equation, A XOR B X nor C. So according to that equation, when suppose any bit changes, suppose this one becomes 0, what will happen in that case? It will become, it will violate this equation at any cost, because this equation is based on that the number of 1 in the equation is 3, and here the number of 1 became 1. 2. So in this way, we can detect any error in the circuit or in any deterioration or noise injection in the message. Similarly, we can extract even parity. For even parity, the equation will be same, but the difference is the final equation will be x is equal to from same method a is or b is or c. The final equation will be a is or b is or c for even parity by using same method. Anyone have any doubt so far?
So, what if instead of 1 bit, 2 bits change?
No, parity is only used for 1 bit because 1 bit is enough to detect the error in the code. We don't need 2 bit to detect the errors. There is no way that if any of the bit will change here, any of the but if the 2 bit changes at a time, then this system will fail. Because suppose 0 becomes 1 and 1 becomes 0, it became 1 and 1 became 0. So in that case, the number of 1 is now the number of 1 in the circuit is even, and it is also working. Odd parity is still working. So this type of error will not be corrected by the odd parity or even parity. It is only applicable for 1 bit change in the basic. Any more doubt? Because if 2 bits are changing, the number of 1 is even now even, and previously it was even. So it will now again act as a odd parity because the number of 1 in the circuit is odd. So it is applicable for only 1 bit. If only 1 bit will change, it will detect the noise or error. So what are 1s complement and 2s complement and why they are used? Can anyone tell me? What is the main purpose of why are 1s complement and 2s complement are used?
For negative numbers.
Okay, and any advantage of 2s complement?
Subtraction.
That is one of the main advantage.
MSB bit can be copied.
Also, the one of the main advantage of 2s complement is that in signed bit notation, the 0 has two values, +0 and -0. So, and in 2s complement, we have only 1 0. So this problem is resolved while using the 2s complement. So how is 2s complement is suppose we have any number, we have to subtract 5 minus 7. So binary number, it is very difficult to subtract 5 minus 7 using normal subtraction. It becomes too complex. So